I'm Dr. Neeta Kumari. I'm from BIT Meshra, and this is part of my PhD work. So it's a very small piece of work that I'm going to present here. And in this, please next slide.
Go further close. That is the purpose of this. Yeah, this
So this is the content of my presentation. So in this presentation, we have done sampling from mainly western parts of Jharkhand like Palamu and Garhwa, and 135 locations we have sampled, and in that case we have taken dug wells, hand pumps and shallow aquifers. So as per the depth wise, we monitored fluoride variation as per the depth, and various other chemical parameters also assessed like calcium, magnesium, depth, pH. So as per by getting data and trends, we analyze what are the relationship between the fluoride differences, fluoride content and the other chemical parameters. So not going to. Yeah, so. Just enlarge it. That's fine. Right. So this is the background, like groundwater is the primary natural resource and supports all types of life forms. And as per the standards, when we go through the standards, like for fluoride, WHO recommended permissible one is 1 mg per liter, and the desirable one, and the maximum permissible limit is 1.5 mg per liter, beyond which is the water is not acceptable for the drinking purposes. So fluoride content in groundwater is a function of factors like presence of fluoride minerals and their solubility in nature, and the fluoride solubility in water is mainly pH dependent. So velocity of flowing water, like earlier we have seen in the case not addressed, that if hydraulic conductivity is more, then water is much better than in like in summer when there is less recharge. So fluoride maybe chances of getting more concentrate. So there is no dilution of that particular content of fluoride. So it may be like at one time you are getting less fluoride, and in another season, like mostly in summer, you may get more fluoride. So basically the hydraulic conductivity which sometimes governs the content of fluoride in the water, and fluoride problem is basically geogenic in nature. So rock water interaction is very important. So so pH, as I already said, that the solubility is pH dependent. So generally we found as per the literatures that higher pH fluoride get dissociated from the minerals. So it enhances the content in the groundwater. Then definitely temperatures, at high temperatures fluoride get dissociated and tend to get dissociated. And then calcium and bicarbonate ions, like calcium deficient waters have more fluoride, because calcium has tendency to bind with the fluoride and they form calcium fluoride which get precipitated out. So this is and which is highly insoluble in water. But if there is calcium deficient water and more sodium is there, then sodium binds to the fluoride, and this is highly soluble in water, and whenever temperature rises, fluoride get dissociated from the sodium and it leach out to the ground. So it enhances the amount of fluoride into the groundwater. These are some of the literature that I've gone through, and mainly more fluoride is if fluoride content is beyond the permissible limit, and if you are consuming that, then you will find some a disease which is called fluorosis, and there are two kinds of fluorosis. When it is related with the dental structure, it is dental, and when it is related with the bone skeletal thing, then it is skeletal fluorosis. Then as per the IS 10500, the limit is 0.6 to 1 mg per liter. If it is beyond 0.6, it is okay, within the range of 0.6 to 1. But if it is less than 0.6, the water should be discarded, because fluoride at one time we needed for the good dental structure and good bone structure. And if it is 1 mg per liter, it is desirable. But beyond that, something should be done for the management, and beyond 1.5, it should not be consumed. But as per the territorial and geographic location where water sources are not available, sometimes they consume it beyond that also. So as per the literatures, these are the fluoride is positively related with the sodium bicarbonate, electrical conductivity, phosphate, and negatively correlated with the calcium. These are the metabolism. This was the study location, material methods. The correlation analysis I did. This is just a statistical analysis through which I tried to find which one is the highly correlated one. So in this, magnesium was found the highest one and pH is least one. And the same, the whole point where observed fluoride value associated with the type of well was found like this, and with the depth. Like deeper aquifer tend to have more fluorides, and in my study I have found 6.1 mg per liter, highest fluoride content. This is a polynomial fit plot from where I have got R square values with the different parameters. And finally I have got the highly correlated one as sodium, and least one is potassium. So these are the conclusions. These are references. Thank you.